Good afternoon. So here we present our first deep learning project. When my partner and I learned about generating images, we knew that we wanted to work with this and learn a little bit more about it. So specifically, our objective in this project was to generate Monet style paintings using DC GANs or other possible techniques that exist out there. So we wanted to be a little bit like Bob Ross, so we took inspiration from that. so uh, our dataset specifically consists of 300 Monet paintings size 256 by 256, and then also 7,028 photos in the same size. And essentially, these are the styles that we're applying to these 7,000 images. That's the objective. So, here's our photo, picture of our photo, and here's a picture of the Monet style picture. And moving on. Instantly, we knew that these images were really large and they would take forever to train. So we decided to scale these pictures down to 32 by 32 to make a feasible training time. So here's our picture of our original, and here's our resize. So we do lose some kind of detail, but at the cost of training faster. So it should be okay. So some basic data analysis here. So here we're just printing some random batch of our Monet style paintings. So this is what they look like. And then here we are printing our color visualization. So pretty much trying to see which colors are more present in these images. So here's a kind of really balanced. So red, green, and blue is pretty balanced in here. And then here we can see that there's a lot more red going on, and as you can see very evidently, here's a lot more red and like a little bit less blue, some green here, so it makes sense how it is portrayed. And then here we are actually generating our DC GAN for all the generator stuff, our training stuff, our discriminator, and so on and so forth. And this was all taken from, of course, the notebooks that was presented in class.
Following on, we simply decided to use the code that was provided to us during the Cipher 10 assignment. So instead of generating numbers, we try and generate Monet style paintings. And by tweaking the code, we were able to do it and generate some successful images, but they are not that good still to our liking. We had to use 32 by 32 images, so we scaled down the Monet style paintings. Since we try to use the 250 by 256 complete images, it will normally crash our session. Since we didn't obtain the desired results with the GAN's model, we decided to move on to neural style transfer. This is a computer vision approach that combines two pictures, a content image and a style image, where the output image keeps the essential components of both the content image while appearing to be painted in the style of the reference image aesthetic. To do this, we first load a pre-trained model to extract the features of the content image and the style image. So in here we can see that we load the pre-trained model, and then we try to also load the images that were downloaded from the Kaggle dataset of the Monet style paintings. We can see here that we have a content image and a style image, and our target image will be the combination of these two. So in here we just get the features of both images by using the pre-trained model. Now that we have our features extracted from both images, we have to explain the gram matrix is before explaining how we calculate the loss. In simple terms, we apply a 2D convolution on an image, which then generates different matrices called feature maps. These maps contain low-level features of the image, such as lines, edges, dots, curves, and so on. The issue is that these are independent from each other and cannot capture styles such as brush strokes or color distribution. So to capture this, we need to find the degree of correlation between our feature maps, which are the edges, the dots, and the curves. And to find the correlation between them, we just have to calculate the Graham matrix of them. So we then grab the features of the content the content image, the style image, we calculate the Graham matrix of the style image, since we don't need to calculate the Graham matrix of the content, since we don't care about the style of the content feature. And then we clone the content feature as our target, and we will keep updating this target to generate our final image. As a sum of the content loss and the style loss. The content loss is the mean square error between content image and target image, and on the other hand, the style loss is the mean square error of the Graham matrix of the style image and the Graham matrix of the target image. And after training our model by a certain amount of epochs, we can see that the target image starts being created. We'll change to apply the style of the style image, and in here we can see the results of our neural style transfer.
Alright, so the last concept that we visited was that of cycle-generative adversarial networks, or cycle-GANs. And so it's pretty similar to GANs, but instead of having one generator and one discriminator, we actually have two generators and one discriminator. And so the two generators work with each other, pretty much allowing them to get more feedback from one another and for each image generated. So the idea is that this will ensure that each generator is cycle consistent. So this means that the generators will get penalized for every detail that isn't similar to the original image when making these image translations. And so we found a research paper where they combine VG19, this is convolutional neural network that is pre-trained, and they combine it with cycle-GANs, and they pretty much say that the resulting images are really good. However, we did not have enough time to actually try this, but according to that research paper, that combination of VG19 and cycle-GANs will end up in great results. So that is something we would have loved to try. And so yeah, I think that will conclude our project. Thank you.